Hello engineers, welcome back. In this video, we're going to continue learning about sorting algorithms, and in this video, we're going to look at selection sort. I hope you're ready. Let's get started. So in this video, we'll see how selection sort works. So let's take an array. Let's take a similar array as last time. Let's say 5, 6, 3, 4, 1, 2, something like this. And the idea behind selection sort is very simple. You iterate through the array and find the smallest element. And once you find the smallest element, move it to the front. That's all. So we go through the array and find the smallest element and move it to the front. And we repeat the process. We go through the array again. We find the smallest element, move it forward. We repeat it again. Find the smallest element, move it forward. Find the smallest element, move it forward, and so on. Okay, this is how it works. So let's do a dry run to understand this better. So let's take our array 8, 7, 5, 6, 3, 4, 1, 2. So we do this using two pointers. First is the I pointer and the second one is the jth pointer. And we keep track of two things, which is minimum index and minimum value. So let's see how this goes. So for the first pass, we assume that whatever is at the 0th position is our minimum index. So if these are my indexes, 0, 1, 2, 3, 4, 5, 6, and 7, we will assume that whatever is in the first position is our minimum value. So minimum index is 0 and minimum value is 8. And we move our j pointer forward all the way and check if there is anything lower than this value. If we find anything lower than this value, we update this table. So j goes forward. Now, right now j is here and the value at j is 7. So this is lower than the current minimum value. So we update it. Now current index is 1. Current minimum index is 1. And j will move forward. Now j is at index 2, which is having the value 5. This is less than the current minimum, so we update it. And j moves forward. Now j is at index 3. Now 6 is greater than the current minimum value, so nothing to do. We can move forward. Now we have 3. 3 is less than the current minimum, so we update it. Index 4. And we move forward. Now we have 4 at index 5. 4 is greater than 3, so nothing to do. We can move forward. Now j is at index 6. The minimum value is now 1 with index 6. And j moves forward. Once j is at index 7, 2 is greater than 1, so nothing to do. So after this inner loop is passed, we check. What do? We swap the current minimum index with the ith position. So whatever is there in the ith position, we swap it with the minimum index, because the concept is find the smallest element, move it to the front. So we found the smallest element. So this is smallest. The index 0, whatever is at index 0 is the smallest. So this is the smallest. So we simply swap. So 8 goes here and 1 goes here. That's it. Now I can move forward. So the inner loop is done. Now outer loop will continue. Now I is at index 1 and our j will come back to its original position and restart from here. Now again we will assume that whatever is at I is the current minimum. So our minimum index table is also refreshed. So all this is refreshed because we are in a fresh loop now and all this is done. Now j is at index 2. So I said that we will assume that whatever is at index I will be the current minimum. So index 1 is the current minimum with value 7. So j is at index 2. The current value at index 2 is 5. So 5 is the current minimum, index 2. And j will move forward. So j is at index 3. This is greater than current minimum, so nothing to do. J moves forward. We have 3, which is less than current minimum, so we update. Index 4. Now j will move forward. We have an element which is greater than minimum value, so nothing to do. We have an element which is greater than minimum value, so nothing to do. And here we found an element which is less than the current minimum, so we update it. So current minimum is index 7. So our inner pass is completed. Now we swap with the ith position. So whatever is in I comes out, and current minimum index is at 7. So this goes here. And our inner pass is done. And I can move forward. Now I is here. We will refresh our minimum index table, and now we can assume that whatever is at I is the minimum index. So I is at 2, minimum value is 5. Now j can move forward. Now j is here. Is it less than the minimum value? No, so nothing to do. J moves forward. Now we found 3, which is minimum, so we will update it. Minimum index is now index 4. And j moves forward, moves forward, moves forward. Nothing is lesser than 3, so we will end our inner loop here. And now inner loop is done. We need to do the swap. So swap whatever is in ith position comes out, and what is the minimum index? Index 4. Index 4 is carrying the number 3, so this will move forward, and 5 will come here. So as you can see, the first elements are getting sorted. So the smallest element came first, then the next smallest element, then the next smallest element. Okay, and our inner loop is done. And now I can move forward. Okay, now I is here. We need to refresh our minimum index table and we restart. So the current minimum index is now 3 and the value is 6, and j is at index 4. So we get the value 5. This is less than the minimum value, so we update it, index 4, and then j moves forward. We find another minimum value, so we update it, index 5, and j moves forward. There is no other minimum value than less than 4, so our inner loop is done. Now we do the swap again. So we are here, whatever is in ith position will come out, and whatever is the minimum index, which is 5, will go here. And that's it. Inner pass is done. We can clear our minimum index table as well, and our I will move forward. Now we repeat the process. We assume the minimum index now is at I, which is index 4, value is 5, and the j is here. So is the value at j less than minimum value? No, so nothing to do, nothing to do, nothing to do. So now we can do a swap. So we are at index 4, I is also at index 4, minimum index is also at 4, so no need to swap in this case. So we can simply move forward. So our inner loop is done. We can refresh our table, and I also can move forward. Now we reset our index table. Now index is at 5, value is 6, and j is here. So value at j is not less than current minimum, so nothing to do and nothing to do here. So the value at minimum index is 5 and current I is also 5, so no swap required. We can move forward. So our inner loop is done. We can reset our index table. We can even move our I, and that's it. Now we reset our index table. We said current value at I is the minimum index, so this is 6, value is 8. Now j is here. Now value at j is less than current minimum, so we update it. Index is 7, and that's it. Our inner loop is done. Now we do a swap. Whatever is at current I will come out. Whatever is in the current minimum index will take its position. And we can finish the inner pass, and now we can also finish the outer pass because there is nothing else to compare, and we have ended our sorting logic. Okay, so now we have a sorted array. So this is the concept of selection sort. Okay, let's try to code it. So let's create a new file, selection sort.cpp. So let's get our template. Let's get our array. 87563412. 87563412. And we can just copy the logic from the previous video for printing before sort and after sort. And now we will build our sorting logic in between. This is selection sort. Okay, so now we take our outer loop, which is int I equal to 0, I less than n is the size, I plus plus. So let's call our size variable int size equal to 8. And now we need to keep track of minimum index. So int minimum index equal to I. Whatever is at I, we assume that it is a current minimum index. And then we start our inner loop. Int j equal to I plus 1, j less than size, j plus plus. So this loop will keep checking if there is anything less than the current minimum index. So if a of j is less than a of minimum index, then we update the minimum index equal to j. So whatever is at j is now the new minimum index. Okay, so after this loop is passed, what we need to do, we need to check if current minimum index is not equal to I. So if it changed, if the minimum index has changed, then we need to swap. So how do we swap? We simply take a temp variable, we call it, we save a of I here, and we change the value of a of I to a of min index. Whatever is in the current minimum index, that gets moved forward. And then we have a of min index will get a of I. So whatever was there in the index of I, that gets moved forward. That gets moved into the minimum index's position. Okay, so it's a swap. So this is swap. I think that's it. Let's try to run and see. Oops, I think we made some mistake. Let's see. I found the mistake. So we just did a mistake during swap. So this should have been temp. So we have copied the value in temp, but we have not used it. So that was a mistake. So let's run it. And now our array is sorted. Okay. So that's how selection sort works. So if you have any question, you can definitely ask me. Please don't forget to like the video. Please subscribe to the channel if you haven't done already, so that you don't miss out on any future videos. And please do comment if you have any questions or any suggestions. And I'll see you in the next one. Thank you. Cheers.